In this example, we are going to find the discontinuities of this function here, f of x, that is defined piecewise, okay? Is x, if x is less than 1, is negative x plus 2, if 1 less or equal than x less or equal than 2, and then 3x plus 1 if x is bigger than 2, okay? So first, because it's a piecewise defined function, first we need to see how the individual pieces are. Okay, but in this case, x, negative x plus 2, and 3x plus 1, these three are continuous. They are standard functions. They are polynomials. They are linear, actually. Okay, so they are continuous. So if there is any discontinuity, it has to be at x equal 1 or x equals 2. Okay, because that's where the function changes from one piece to the next. Okay, so the discontinuities, if any, must occur at x equal 1, 2. Okay. Well, so let's look into it. Let's do first x equals 1. Okay, what we need to do here, remember, to check if the function is continuous, is to see if the limit exists. Okay. What is the value of the limit? And see if it equals the value of f at the point. Okay. So let's work on that. So because this is defined piecewise, we need to check the limits, the lateral limits. Okay, so we need to see from the limit x to 1 from the right and from the left. So f of x from the right is going to be negative x plus 2. Okay, and from the left is going to be x. Okay. And then when I plug x equal 1 here, what I get is negative 1 plus 2. This is 1. And then here I get 1. So the two of them are equal. So the limit exists. Okay. That's a good thing. Now we need to check if f of 1 exists, and if so, what is the value? So f of 1, if we look at the definition, we need to use the second piece. So it's going to be negative 1 plus 2, which is 1, and coincides with the limit. So what happens then? F is continuous at x equals 1. So we are good here. Now we need to check what happens with x equals 2. Okay, this is very similar. So what we need to do is to compute the limits from the right and from the left. When x tends to 2. Okay, now when x tends to 2 from the right, if we go back, we have 3x plus 1, otherwise negative x plus 2. Okay, so this is 3x limit x to 2 plus 3x plus 1 limit x to 2 minus, and this is negative x plus 2. In this case, we have 3 times 2 plus 1, which is 7. And then the other one is negative 2 plus 2, which is 0. Okay, so in this case, these two are different. Okay, so no chance. Okay, the limit does not exist. And therefore, f has a jump discontinuity at x equals 2. Okay, and if we want to graph this function, because it's a linear function, it's very easy. Okay, it's going to look something like this. So we have x. So we have the two discontinuities. Let's start there. Potential discontinuities. This would be 1 and this would be 2. So we have that f was equal to x all the way until up to 1. Okay, then at 1, it would change to negative x plus 2. So that's a function that comes from here, from 2, and goes like this. Okay. But I don't actually need the whole thing, so let me get rid of that part. There we go. And then it continues. It continues from here onwards. Okay. So yeah, so that's it. So we have here 2 is included, and the upper part here it's not included. So we see that clearly there's a jump. And we also see that we can pass through x equal 1 without lifting the pen from the paper. Okay, even if there was a corner, that doesn't matter, that corner. The function is perfectly continuous at x equal 1, but it's not at x equal 2.